Hello everyone, welcome to the 11th module or 11th week lectures on smart building sensors. So we are discussing a course on microsensors and nanosensors, and in the next two modules, particularly this module 11 and 12, we are going to see the applications of all the sensors that we have covered till module number 10. We have covered, I think, nearly all kind of day-to-day used sensors. Maybe it's an active sensor or it's a passive sensor. We have covered that till module 10. What we are going to do is we will be using these sensors that we have discussed till now along with some other kind of modern devices for few applications. Particularly two important applications that we are targeting is one is the smart building sensors, and another is the sensors used for human well-being or diagnose human health. Okay. So in this module, as I have mentioned, that we are going to talk about smart building sensors. But before we actually dive into different sensors in this module, let us try to understand that why we are studying this, why there are requirement of sensors in a building, and when this requirement is fulfilled, why we are calling it a smart building. Okay. So to understand that, we have to first understand that the buildings actually around us consume more than 40%. In fact, the data suggests that the energy consumption by the buildings, be it indoor, be it outdoor, is reaching anything above 45%. Okay. So that much energy, if the world require 100% energy to operate, 45 to 50% is required by these buildings, right, and rest is distributed among industries and other uses. Okay. So it's a large chunk of energy is going to be consumed by these buildings. Okay. And if I understand the pattern of energy consumed by this building, it will not be only beneficial for the better operation of the building, but it will also be helpful for the occupants who is staying in those buildings. Okay. So the optimal control of this building environment variable, for example, the physical parameters, say temperature, humidity, the lighting inside this building, has significant impact on indoor environment quality, and it will affect the quality of life of the resident person. Along with, it will also be responsible for the building energy efficiency. Okay. So it doesn't only cover the pattern of energy consumed by the buildings, but it is also directly responsible for the well-being of the resident who is staying in those buildings. Okay. So there are requirement of to measure all these things like lighting or heating, say ventilation or the air conditioning of the buildings. Okay. And for those monitoring, we require several sensors. Okay. So a variety of sensors can be connected to all these places, be it say the lighting element inside a room. It can be a simple bulb, it can be a tube light, the heating elements, the ventilations, okay, and the HVAC systems that is required for air conditioning in a building. Okay. So the as I have mentioned, that energy consumption in the built environment relates to occupant behavior in the building. Okay. How say there are two buildings, say building number 1 and building number 2. Okay. And say I am supplying, say, energy, say I am calling it building 1. Okay. And I am calling this a building 1. Okay. Building 2. Okay. And there can be other cases also, we can compare them. Okay. Say building A and another building is building B. Okay. Now I am calling this like building 1 is a normal building. It is not a smart building. I am calling it a non-smart building. Okay. Although should not use this kind of terminology, but let's call for a time being it's a non-smart building. And at the same time, I have another building. This is building number 2, which is a smart building. Okay. Now say I am providing X unit of energy to both the buildings. Okay. So 2x was the initial energy supplied to the buildings, and say X is being supplied to one and Y is, or another X is being supplied to building 2. Okay. Now, out of this X, okay, building 1 consume around 45%. Okay. So, the consumption by building 1, for example, is 0.45 of X, same is being consumed by building 2. Okay. Now, you can say that the quality of life means includes, how the air conditioning is done in this room, how the lightings are placed inside this building, okay, how the temperature is being controlled in building 1 and building 2. These define actually quality of life inside these buildings. Okay. Now, by seeing just this data, one can suggest that if they are of equal area and everything is same, okay, considering all these things, one can say that the quality of life of the occupant in building 2, which is basically a smart building, is better as compared to quality of life in building 1, because it can be a case that out of this 0.45x of energy that is being consumed by building 1, okay, is wasted, because say by heating something or providing light. So it can be a case like if this is building 1, there is a 200 watt bulb glowing in this area, okay, and this particular portion of this building is not being lighted, okay, because there are not sufficient sensors installed in this building which can tell that if the occupants are not in this area, say this represent occupants, if the occupants are not in this area, they have moved to this area, automatically it should be in smart buildings, these lights should be off, okay, and some light somewhere here will be glowing or somewhere here will be glowing. Okay. This is just one case. There can be cases that there is a heating element placed over here for heating in winter, okay, and say in summer also it is glowing, because there are no sensor, nobody has checked that, and that this is still glowing. Okay. However, in a smart building, I will show you that there are number of sensors installed. Okay. So I can ensure that the 0.45x of energy that is being consumed by this building 2 is being utilized properly and for the benefit of the occupant in this building. Okay. And that's the difference between a smart and non-smart building. Okay. And the energy consumption in the building environment relates to the occupant behavior in the building. Okay. So there can be other example, like say out of this 0.45x, okay, now out of this 0.45x of energy that is being supplied to building 2, okay, how this energy are distributed. Okay. I mean, it can be for providing heat, for providing lighting, is consumed by air condition. Okay. It can power up cameras and other things, right? So this pattern of consumption of energy by the occupants actually define that what is the behavior of this the occupant inside the building. Okay, like if it is a smart building, okay, say there is one occupant, I am talking about this building A, there is one occupant of this building, say he is coming in this house, say at some time, say at 8 p.m. in this building, and he watches television which consume around say 0.01x of energy. While he consumes this television, he is using the air condition in this particular area which require another 0.1x of energy. Okay. then he light up this area which require 0.001 x. Okay. So in total he is using 0.111 x of energy. Okay. And this is happening from say 8 p.m. to 10 p.m. Okay. And after that he switch off this area, or it get automatically turned off. Okay. And say he is occupying this particular area. Okay. Where he is using another HVAC system. Okay. Which again consume another 0.2 x of energy. So in total he is utilizing 0.311 x of energy. Okay. Any deviation from 0.311 x, okay, can tell us about the behavior or the pattern of the occupant, how he is utilizing these instruments, or this how he is utilizing his house. Any deviation from this 0.311 x can tell about that, right? So that's why I mentioned that energy consumption in the built environment relates to the occupant behavior in the building, right? Knowing the fine-grained occupancy information in the building environment is an important parameter for efficient energy use. Okay. So if I know that say if I am designing this smart building, if I know that how this occupant is going to utilize say his living area or say his dining area, okay, I can design this house in such a way that if I see from energy point of view, that can be optimized. All right. All these things that I am talking about are based on sensors. Okay. So whatever we have discussed till module 10, actually we are going to utilize all those things, right. So all these things, as I have mentioned, are based on the data acquired by the sensors placed in different places. We'll see how this what are these sensors at least in this course and how they are placed. Okay. The sensor information helps to analyze the occupant behavior and presence pattern, as well as it also provide the thermal and visual preferences of the person. Okay. This facilitate the building automation system to create a better control of energy uses and indoor environment quality. Okay. So occupants' productivity as well as the health are highly influenced by the indoor environmental qualities. Okay. Now maintaining the optimal comfort zone is critical to the built environment. Okay. So if the indoor environment of this building is not comfortable for the occupant, okay, he may not like to stay in that particular building, or it can deteriorate his health. Okay. Therefore, these buildings require a lot of sensors, and when these sensors are placed in a definite fashion to acquire this data, we call it a smart building. Okay. So let me list out some sensors which is required in a smart building, and then we will discuss some of them, at least those which we have not discussed in till our module 10. Okay. So some of the sensors that are required are occupancy sensor and motion sensor. In our module 9, we have talked about this occupancy and motion sensors in more detail. Okay. We'll try to cover some other kind of occupancy sensors which are used in modern buildings. Okay. Then another kind of sensor which is very much essential in smart buildings are air velocity measurement sensors or air velocity sensors. Okay. So this air velocity measurement inside a building is very important, particularly for the comfort of the occupants. So we'll see some of the air velocity sensors required for the better building management. Okay. Then we'll also talk about pressure mats. These are essential, again sometime utilized for pressure measurement, sometime required for occupancy, sometime for motion detection, depending on what application you are using. Okay. So we'll talk about this pressure mats in a little detail. Okay. Then sound sensors are something very important for the comfort of for the comfort of the occupant inside the building. You can also relate it to, say, ultrasonic sensors, okay, although sometime, or it can also be related to noise sensors, okay. There are slight differences among them, but sometimes they are used for similar applications, okay. Then you have VOC sensors, volatile organic compounds. Detection in a indoor environment is very much crucial, okay. So all these buildings are painted by some acrylic material or by some polymers, okay, and when sunlight falls on it, or even the light from the indoor lighting equipments, if it fall on the wall for longer time, if it is exposed, okay, it starts emitting certain volatile organic compounds, because they all are made up of some polymers, okay. And when they start emitting till certain concentration, it can be allowed, okay. However, if it starts emitting very certain VOCs like CO2, for example, or formaldehyde or some other acetone, okay, that kind of VOCs, if they start emitting from the wall, or by some other chemicals that are placed inside home, or by food, by fermentation of food, or by anything, okay, it not only causes the discomfort for the occupant, but it also starts making his stay unpleasant, okay. And at the end, it can also cause health degradation of that particular occupant, okay. So we require these smart VOC sensors in these buildings, okay. Other sensors that are required for a smart building are like photosensors. Sometimes carbon dioxide sensors are segregated from VOC, so you can say that CO2 sensors. Then ambient temperature sensors that are very much essential and integrated with several systems inside a building, okay. Then certain instrumentation like for current measurement, for power measurement, and say some voltage fluctuation measurement, that kind of devices are also required for a smart building, okay. This smart building is incomplete without having water flow sensors. So in whole my building, water pipes are circulated, okay, because I have to take that water tap into my kitchen, as well as it has to be in washroom and other places, okay. So water flow sensors are very much essential to detect any leak or the flow rate of water inside these tubes, okay, or the pipes, okay. So water flow sensors are nowadays essential for any smart building, okay. Then comes the sensors required for the comfort of the occupant, and the sensor which is of utmost importance for this kind of comfort is humidity sensor, okay. Then along with sound sensor, you also require acoustic sensors inside building, okay. Then there are modern sensors like wearable devices for physical and chemical parameter measurement of a human being are nowadays required for a smart sensor, okay. And some of the smart buildings are integrated with smart heart monitoring systems, okay, as well as some skin temperature measurement devices, okay. So these are certain modern sensors that are required in the smart building concept, okay. What we will do is we will try to discuss some of these sensors in detail, at least from the application point of view, okay, so that you understand that how these smart buildings are designed based on the sensors that are required for developing this kind of buildings, okay. So let us recall the occupancy sensors that we have discussed in our module 9, okay, where we have talked about various occupancy and motion sensors based on ultrasonic principle, as well as based on microwave, based on triboelectric, capacitive and optoelectronic. Okay. So these sensors can be utilized in the modern smart building managements. Okay. However, along with this, there are other kind of devices also that are required for the evaluation of occupancy of a room or of a chair or any other place inside a smart building, as well as the movement of the occupant inside a building. Okay. So some of the sensors that we have not talked in detail in our module 9 are some say camera based or image based sensors. So you have image based sensor where you utilize computer vision for detection of a person using certain cameras. Okay. Then you have time of flight or 3D cameras where you use time of flight light detection for the behavior of occupant, particularly in occupying certain areas. Okay. Then you have this popular PIR sensor. We have discussed that in detail, which we call passive infrared sensor for by detecting human body heat or the object's heat which is emitting certain wavelength of mid IR. Okay. Then we have talked about ultrasonic and microwave sensor which are based on reflection of ultrasonic and microwave light respectively from the object which we want to detect, and these were based on Doppler's effect. We have discussed that in detail. And then we have pressure sensors, which is which utilizes floor mats kind of thing to monitor that if there is a pressure change because of the occupancy of a chair by the person or by the movement of a person inside a room. Okay. It can trigger certain alarm that okay, the person is moving or certain area is occupied. Okay. So what we have not discussed is actually image based sensors. So what we are going to do is we will discuss image based occupancy sensors which are of course based on cameras. Okay. So image based sensor work with the electromagnetic radiation techniques. Okay. And the advantage of this kind of devices are they store the information in a matrix form which can be fetched later on, even the person has not occupied that area sometime later. Okay. So you have a camera or image sensor which capture the room or space which is under monitoring, and then you have a processing unit where the data can be processed and accordingly decisions can be made. For example, if the person is occupying this chair, okay, the say smart heater inside this chair will be on. Okay. And when he is not occupying, the processor unit will give information to the intelligent system inside this chair that okay, the person is not occupying chair, and the heater will be switched off. Alright. So along with this there are concept of automation by building management systems which can take decision, and based on negative feedback you can have a very stable this sensor system. Okay. The image based sensors include various cameras. This include infrared based cameras. They can also have luminance cameras as well as a normal visible light cameras are very popular for image based sensors. Okay. If you are using infrared based cameras, the thermopile array will be used for image detection. Okay. And the visible light camera uses a combination of image based and multi infrared sensors for occupancy detection. Okay. We know that in all these buildings cameras are installed for security purposes. So you do not have to actually install camera for occupancy detection. Okay. The camera that are being installed by the security team for security purposes can be used for occupancy detection only. Okay. So cameras are used to identify the occupant position, their activity when you have camera arrays, and it can track actually the occupant inside a building. Alright. So the occupancy detection is determined mostly using visible light camera sensors and the luminescence camera as compared to the IR camera. IR cameras are not that much essential, particularly if your building is not, it's not a kind of military application. If the building is not being used for those kind of application where you do not need, where you have constraint of switching on lights and other things. Okay, mostly these buildings are occupied provide with lights. So a visible light camera or a simple luminescence based cameras can be integrated in this. Okay, so it doesn't require a lot of IR cameras, because it will also increase the overall cost of the smart buildings. Okay. Also, their reliability and accuracy is also something, if it is not integrated with the very strong algorithms, okay, they are also challenged. So basically, visible light cameras as well as the luminescence based cameras are more than enough for this kind of applications. Okay. So the image based sensors or the camera based monitoring system for occupancy detection has several advantages, like they are accurate in large and complex spaces, particularly if you have integrated camera systems. Okay, you do not have a physical contact with the users, so basically you are not worried about tracking by the occupant. Okay, so basically you are tracking the occupant is not tracking you. Okay, so it can also provide occupancy pattern, and you can analyze the data that what is the behavior of the occupant based on say over 10 days or 15 days data of the person, or it can be even extended to say even for months or even for years. Okay, so it can give you a pattern of occupancy by that the occupant. Okay, it is versatile in nature, it can detect other objects as well, so you do not have to actually install another set of camera or another set of sensors to detect other objects or other foreign elements in the occupant area. Okay. However, it's not that there are only advantages associated with this image based sensor. Although the system seems to be very simple, there are several disadvantages also. Like the major disadvantage of this camera based system are there is a need for a clear line of sight for the camera. Okay, so if the object is not in the line of sight of the camera, or if you do not have a sufficient number of camera to track all his position, okay, you will not be able to track the occupant's behavior. Okay, so a line of sight for camera is essential for monitoring the pattern of occupancy. Okay, the placement of these cameras are a major concern for image detection. Okay, so if you are placing the camera in such a way that the occupant is not in his line of sight, or if his, say for example, there are 10 rooms, and if I have installed it in room number 1 where occupant actually do not go regularly, okay, you may have zero data. All right. So either you have a large number of network of this sensor, or the person should be in line of sight, as well as you have to be very careful while placing these cameras. Okay, they are actually expensive. They have actually very expensive hardware for signal processing that is required for occupancy detection. If you want to have a count of the occupants as well as their identification and their tracking, so it requires a large investment in their signal processing and data analysis also. Okay, so this is the sensor that we have not discussed while discussing the occupancy sensor in module 9. Then along with occupancy, there is another kind of device which is required for tracking the motion of the occupant. So whenever you talk about occupancy, you always talk about motion detection, right? So motion sensors are used to determine the occupancy presence as well as his behavior inside the particular area. Where it becomes more significant actually when you talk about indoor movement or indoor behavior of the occupant. Okay, and commonly used motion sensors are PIR sensors, ultrasonic Doppler sensors, photo sensors, then microwave sensor, which is again based on Doppler effect, and then you have ultrasound ranging kind of devices, right? So we have talked about the passive infrared sensors in more detail in module 9. The PIR sensor is able to only detect the occupant presence in an office building. Okay, however, it doesn't count the number of occupants in the zone. Okay. The disadvantage is that when the occupant is not moving for a long time, the sensor note it as a false signal. Okay. So although he is present, you are not getting any signal, or this data you may not rely upon. Okay. So PIR sensor is good enough when you only deal with if the person is present or not, but when you actually talk about tracking his movement or tracking his continuous changing position, okay, you have to rely upon other sensors. Okay. So photo sensors are very popular motion sensors. Okay. And the detection of motion is by identifying the light associated with the occupant. It can be interruption in the light beam, which comes under active sensor, or it can be change in the ambient lighting condition, okay, which comes under the passive sensors, because no active light source is involved here. Okay. So all these sensors work on the principle of light reflection, its interruption, okay, by the objects under movement, or by emission of the light by the object itself. Okay. So photo motion sensors can be, as we have talked, it can be active IR sensor, or it can be a passive light sensor. Okay. There are other variety of photo motion sensors also, like laser beam or optical beam sensors, as well as camera beam sensors. So active infrared sensors emit IR light by the source, and it is detected, the reflection or interruption of this light is detected by the receiver or the photo detector. Okay. For the passive light sensor, you have to detect the ambient light changes, which is causing by the motion. Okay. For the laser beam sensor, it actually measure the light which is emitted by the IR beams are detected when the beam is broken. Okay. So you have a monochromatic source of light. Okay. And if the occupancy is moving in this direction, or by some way it interrupts this, or if this beam is broken by some mean, okay, that is detected by the detector. It can be a pyroelectric detector or any other kind of say thermoelectric or thermopile based sensor. Okay. So this broken beam is detected by that, and based on that we can tell the pattern of movement of the person. Okay. And then we have camera based sensor, which is not much effective, but then image processing is a lot of image processing is required to detect motion through frame by frame analysis of the person. Okay. It can be based on comparative analysis, where you compare the object still photo with some moving object frame by frame, or by capturing it live. Okay. It depends on what kind of technique you are using. Okay. However, there are certain limitations associated with this photo sensor based motion detectors. Like the sensor can even be triggered by the heating of wax system or in the office space. Okay. So say if the detector is based on say pyroelectric devices, okay, it can be easily triggered by the heat. Okay, which is of course very generic when the HVAC systems get heated when it is operating for the longer time. Okay. It is affected by ambient light, or even it can be interfered by the sunlight, because it contain all kind of wavelengths, particularly in the visible light. Okay. They have limited range and very limited accuracy. Okay. So you cannot use it for all the application, only for crude application you can utilize it. Okay. These kind of sensors like you have seen that camera based sensors, okay, they require direct line of sight again. Okay. And when you have smoky ambient or dusty ambient, these devices are less effective. Okay. And that's why people rely upon radio based motion sensors. They are very much effective, particularly line of sight is not required, and that is the at most important feature of this radio based motion sensors. Okay. So this type of sensor utilizes a radio signal to detect the occupant's presence in the building environment. Okay. Also, the sensor provides information on the occupant's location, its count, identity, as well as its movement. Okay. The radio signal covers the electromagnetic wave in the range of 10 kilohertz to as high as 300 gigahertz, and it is based on Doppler shift or signal reflection due to motion. Okay, the idea is very simple. You have a sensor which emits the radio waves. These waves get reflected by the moving object. There is a change in frequency associated, or there is a change in the signal phase which has to be analyzed. Okay, and basically you do not need a line of sight kind of arrangement. Okay, the movement can be in any direction, the sensor can be placed in any direction. Okay, the receiver can be at any place. If as far as it is received by it, okay, it can tell about the pattern of the moving object. Okay, so there are different radio based technology used for occupancy detection, particularly in the modern days. You have continuous wave radar or CW based devices. You have frequency modulated continuous wave FM CW based devices, and you have ultra wideband UWB devices. Okay, so these can be again further classified under different heads, but the modern the smart buildings require various kind of motion sensors based on this radio signals. It can utilize certain day-to-day essential radio source of radio waves inside a building. It can be through our Wi-Fi, it can be through Bluetooth detection. Okay, so in general you have radio frequency identification RFID based smart building motion detectors. You have Wi-Fi based smart building sensors, motion sensors. You have Bluetooth based devices. You can also use a global positioning system for tracking motion of a occupant. And you have, as I have already mentioned, that ultra wideband based devices for this measurement. Okay, so let us see the radio frequency identification RFID tags, that how RFID tag can be utilized for motion detection inside a smart building. Okay, particularly for indoor environment movement of occupant. Okay, so radio frequency identification RFID senses the people or object using tags which have a unique code of identification. It can identify both active and passive RFID tags. If you talk about the tags, it can be passive, which doesn't have any battery. It can also be active, which is battery powered, and you can also have semi passive kind of tags. Okay, which of course we are not discussing here, but you should understand that these kind of tags exist. Okay, and the frequency involved are anything from low frequency to microwave. It can also have high frequency or ultra high frequencies associated with it. Okay. Now, motion is inferred through change in the tag and the reader distance. Reader here is the RFID reader, RFID tag reader. Okay, so change in the tag and reader distance, variation in the signal strength, and by the shift of the phase and frequency. Okay, so tag is basically on a person or on the object which we want to track. So tag on the person or object and reader, the distance between them detects movement by analyzing these parameters. Okay, so active RFID tags have a longer range of sensitivity which helps in large office spaces to determine the occupancy presence. Passive RFID tag have a limited range of sensitivity, and the advantage of these devices is you do not require to power it up always with battery. Okay, so although active RFID tags have longer range, but the advantage of passive RFID tags are they do not require a battery component. Okay, so the RFID sensor can be used for measuring the distance and the proximity of the occupant in the building environment. Okay, and the advantage of RFID based motion sensor is there is no requirement of line of sight, which was the major issue with the camera based system. Okay, then real time update of motion triggered operation, which is enabled by power saving, which can enable power saving modes for the devices is possible. Okay, then they have adaptability to for the building security. Okay, so these are certain advantages with associated with this RFID based motion sensors. However, there are certain limitations also for this RFID based motion sensor, including there can be RF interferences. These interferences can be from other electronic components or electronic gadgets around the tag. Okay, then there is a read range variability in different indoor ambients. Okay, if the ambient is say if in certain way, if it is cloudy or if it is filled with smoke, or in if the humidity condition has changes, in those condition the read range is variable. Okay, so earlier, say if you were able to sense this presence of this RFID tag on an object by a reader at a distance x. Okay, and this was at humidity say 80%. Okay, and if the humidity rise to say 100%, okay, the distance x that is required for this reader and the object carrying this RFID tag, okay, will change, and now it may be say x plus delta x. Okay, now earlier you were able to read at a distance x, now you have to be in a close proximity, and a requirement of x minus delta x is required for this distance. Okay, so there is a read range variability, particularly depending on the ambient conditions. Okay, although the devices are cost effective, but then advanced tags can be very costly. Of course, it will carry more information along with the tracking of the motion, but then it comes with the more cost. Okay. So this is very quickly we have talked about RFID based devices. Then there are other devices also, like based on Wi-Fi, Bluetooth and GPS. We'll try to see some of them in our next lecture. However, we have to cover a lot of sensors in this example of smart building. So we'll focus on other kind of sensors also, like the other sensors that I have mentioned was the air velocity measurement. Okay, which is very much essential inside indoor air conditions. Okay, so we'll talk about those kind of devices also in our next class. Okay, thank you.